The most dangerous moment for an industry is often not when nobody understands it. It is when everyone starts to believe it is easy money. Storage has been hot since last year. Many people only noticed it after prices went up, supply became tight, and storage stocks started moving. Before that, most people did not really care about DRAM, NAND, HBM, inventory cycles, disciplined capacity expansion, or data center demand. If you only start to understand storage after the price cycle has already turned, what you are seeing may not be industry logic. It may just be market sentiment. Hi, I am Leon. After this video, I hope you will have a much clearer way to understand the storage industry. Let's get straight to the point. If you understand storage only from the price side, it is very easy to misread the industry. Why? Because storage is not one single product. It is not just hard drives and memory sticks. It is an entire industrial system built around data. Before data can be computed, it has to be read. Before data can be trained on, it has to be stored. As models keep iterating, they create weights, checkpoints, logs, indexes, and caches. In the AI era, data is no longer just sitting quietly on a disk. It keeps moving through memory, SSDs, servers, networks, and databases. So if we want to understand storage, we first need to understand the layers that data passes through inside a device, a server, and a data center. Let's move from the inside out and look at the physical chain of storage. Closest to the compute core is HBM. HBM is also a form of DRAM, but it is not an ordinary memory module. It vertically stacks multiple DRAM layers, connects them through TSVs and a very wide interface, and places them directly beside the GPU package. That greatly increases bandwidth. The stronger an AI chip becomes, the more data throughput it needs. If data cannot keep up, the GPU waits. So HBM is not mainly about storing more data. It is about moving data to the compute unit faster. A little farther out is regular DRAM. It is the working memory used while the system is running. It is fast, but it does not keep data after power is lost. Servers, PCs, phones, and AI training jobs all need DRAM to hold the data and tasks currently in motion. Farther out again is NAND Flash. NAND can retain data even when power is off, so it becomes phone storage, USB drives, solid-state drives, and enterprise SSDs, AI training datasets, model weights, checkpoints, inference logs, vector databases, and enterprise knowledge bases all land in this layer. The outermost layer is system-level storage. This includes server drives, enterprise SSD arrays, distributed file systems, object storage, databases, caching systems, and the data scheduling architecture built by cloud providers. At this layer, we are no longer talking about a single chip. We are talking about how a whole data center stores, reads, scales, and controls cost and power consumption. So the core structure of the storage industry can be summarized in 4 layers. First, DRAM and HBM solve high-speed data supply. Second, NAND and SSD solve persistence and high-frequency reads and writes. Third, controllers, modules, packaging, and servers turn chips into deployable systems. Fourth, cloud platforms, AI data centers, and end customers are both the source of demand and part of system-level integration. Once you understand this structure, it becomes much easier to understand why storage is cyclical. Storage demand changes quickly. Phone replacement cycles, PC inventory, server purchases, and AI data center build-outs can all change demand. But supply expands slowly. Fab expansion, equipment installation, process migration, and yield ramp all take time. When demand rises, prices go up, manufacturers' margins improve, and the industry starts expanding capacity. But by the time that new capacity is actually released, demand may already have cooled. Then prices fall, inventory rises, and capital expenditure is cut. Later, supply tightens, inventory is digested, and prices start to recover again. That is why the storage industry repeatedly goes through cycles. It is not just a simple price-up story. It is the result of demand, supply, inventory, and technology migration pulling against each other. So why has AI made storage visible again this time? Because AI has changed the structure of demand. In the past, storage demand mainly depended on phones, PCs, and traditional servers. Now AI data centers are becoming a new source of growth. Training large models requires GPUs, but it also requires HBM, server memory, and enterprise SSDs. The growth of inference applications creates new demand for vector databases, while the trend toward long context greatly increases pressure on KV cache, memory, and storage. In other words, AI is not just buying GPUs. It pulls compute, memory, storage, networking, servers, power, and cooling together. If any link is missing, efficiency suffers. That is also why we cannot only look at HBM. HBM is important because it directly affects whether an AI accelerator can stay fed with data. But NAND, enterprise SSDs, server memory, controllers, packaging, and system-level storage are also important. HBM solves near-compute bandwidth. SSDs solve massive data capacity and high-frequency reads and writes. System-level storage solves large-scale data scheduling inside the data center. So storage is not a supporting actor in AI. It is the underlying system responsible for data movement inside AI infrastructure. If ordinary investors want to really understand storage, they should not only look at price headlines, and they should not only look at one day's stock price. They should look at several questions. First, are AI server and cloud capital expenditures continuing? Second, are HBM supply, yield, and generation transitions going smoothly? Third, is demand for DDR5 and server memory still growing? Fourth, are NAND and enterprise SSDs truly entering the incremental demand of AI data centers? Fifth, are manufacturers' inventories falling or building again? Sixth, is the supply side starting a new large-scale expansion? Seventh, is technology migration creating new cost and yield pressure? When you understand these questions, you are no longer just chasing a hot theme. You are understanding an industry. The essence of storage is not a hard drive, and it is not a memory module. It is the complete chain that moves data from saving, to reading, to transport, and finally to computation. In the past, storage was often hidden inside product spec sheets. Now, because of AI, it is moving toward the center of infrastructure. The larger models become, the more inference runs, the longer context becomes, and the more complex enterprise data gets, the more important storage becomes. So we are rethinking storage not because it suddenly became a fashionable concept, but because in this AI era, the real scarcity is not only compute. It is also the ability to keep data moving continuously. That is it for this episode. I hope this helps you see past some of the market noise. If you are interested in the storage industry, leave a comment. The voice, the visuals, and the script you heard in this video were all created with AI. But behind large model training and inference are exactly the things we discussed today: HBM, SSDs, and data center storage. Sometimes the end of the industry chain leads us right back to the beginning. I am Leon. See you next time.